We are going to solve the example 2 graphing. So I'm going to start writing the equations, the two equations we have for the exercise. So y is going to be equal x minus 3. This is the first one. And for the other one, we have y is equal negative x minus 1. Okay, this is what we have. This is the same system of equations, only that in this application, I cannot use a bigger of this. So that's the reason why I used two of these symbols, okay? This is what we need to graph. Okay, this is the system of equations. And what we need to do first, write the first equation and the other one. How I'm going to graph this? Remember, we have different ways to graph. The first way could be giving values for x, giving random values, like I told you in class, in the last portion, in the second portion. You start with x in 0, 1, 2, 3, okay, something like that. Or the easiest way is to find the intercepts. You find the x-intercept and you find the y-intercept. So for the first one, when y is equal x minus 3, you are going to find both intercepts. The y-intercept means that x in this point is going to be equal 0. Okay? So we are going to replace the value of x with 0 in the equation. Then y is equal 0 minus 3. X is going to be negative 3 then. Okay? X is 0 and y is negative 3. Now I'm going to find the x-intercept. I'm going to do this for both functions, for the first one and for the second one, okay? X-intercept means that y in this point is going to be equal 0. I'm going to give more space in here. Okay. And now I'm going to replace in the formula that y is equal 0. So 0 equal x minus 3. I only replace in the formula 0 equal x minus 3. Okay. And this 3 is negative in this side, so if we pass it to the other side, it's positive. That means that x is going to be positive 3. Because you have this 3 equal x, we only write it in the, okay, with the variable first, but it's the same. X equal 3. So this is for the first equation. This is for the first one. So if we graph the points, x is 0 and y is negative 3. X is 0 and y is negative 3 is located in here. And for the other point, when y is 0, x is positive 3. So it's in here. We can connect this using this. We touch the 2 points, the first one and the second one, and we have the first line, okay? Later, I'm going to do the same with the other one. If we have the equation y equal negative x minus 1, we need to obtain the both intercepts, y-intercept and x-intercept, okay? So y-intercept means that x is going to be equal 0. Then we replace on the equation. Y is equal negative x minus 1, so y is equal 0 minus 1. This means that y is going to be negative 1 when x is equal 0. okay? And for the other value I need is the X-intercept. Look that I'm doing all the procedure with you. We already know how to graph the functions, but I want you to remember how to graph using the intercepts, and later that you will have this these two lines on the graph, you are going to find one point in common for both of them, and this is going to be your solution. But at the end, we need to prove again if the solution we find is correct, like in the first example. Then I'm going to replace in here to obtain the X-intercept. The X-intercept means that Y is equal 0. So in the equation, if I have 0 equal negative X minus 1, then Y is 0. So what happened with the variable? I have negative X in here, and I pass the negative 1 to the other side, positive. So it's positive 1 equal negative X. But what happened with the negative of the X? I cannot have the X negative, so this negative is going to pass to the 1. I'm going to obtain that X is going to be negative 1. Okay, so negative, I write the intercept in here, and I'm going to graph the points. I'm going to locate the points. For the Y-intercept, when X is 0, Y is negative 1. 0 for X and negative 1 for Y. And in the other point, we have when Y is 0, X is negative 1. Y is 0, but X is negative 1. So what we have is this, and we only need to draw the other line. This, you touch the 2 points, and this is the graph. Okay, now you can see that they are going to intercept in 1 point. So we can mark this point like the point of intercept. We have something like this intersection, and you mark the point in here. Now you can write the coordinates of this point. You can do it easily in this kind of program because you already have the table, okay, with all the values, 1, and this is negative 2. 1 for X and negative 2 for Y. This is for the point. This is the solution because we already solved it in a program that shows you exactly the point. But if you do it on your own and you don't use, for example, a notebook with grid paper, or you don't use the ruler or something like that, you are going to have problems graphing, okay? And you maybe don't find the exact point where is going to be located the intersection. So we always need to prove that is the solution. We always need to prove, even if I found that this is the solution, I need to prove it. Like we solved in the example 1, remember? They give you this value in both equations. So you only prove it. But in this case, no, they don't give you the solution. They give you the equations. We graph each one of them. We write the solution. And now we have the possible solution. We are going to prove it in each equation to see if it's really the solution or not, okay? Then we are going to prove. With the solution I have in the first one, Y is equal X minus 3. So we are going to say that X is 1 and Y is negative 2. So I'm going to replace Y is negative 2. So negative 2 is going to be equal X, that is 1, minus 3. But maybe I'm going to write the equation. I'm going to write the equation again because you sometimes forget about this. I didn't want to write it because you already have it on the book, but if I don't write it, you are going to get used to do something like that. No, I need you to work in order and to show each step. So that's the reason I try to do all these steps with you. Okay, so in this we only need to prove that one side of the equation is equal to the other side. If the statement is true, if the sentence in this case is true for both sides of the equation, we can say that it's solution for this equation. You can see that -2 equal -2 because you subtract 1 minus 3, you obtain -2 because you keep the sign of the greater number. And for the other equation, we have that y is equal -x minus 1. We replace the values again, we replace the value for x and we replace the value for y. So for y, I have -2 equal -x, but x is +1. So we are going to have -1 minus 1. So you have that -2 is equal -2. And what we say in this part, the ordered pair, we copy the ordered pair, 1, -2, is a solution for the system of equations. Okay, this is what we have in here. The ordered pair, I don't know why this showed me the both equations in the same. Okay, it showed me the both equations in the same line, but you know that we prove it one by one. It's a mistake when we separate them. But you already proved because we need to be sure that the equations are going to be completed with these values you have. You replace the values to see if the sentence you obtain, if the statement is true, okay? If it's true only for one equation and not for the other one, then it's not going to be a solution for your system of equations. This point has to be a solution for both of them because you can see that it's one point that is located in both of your equations, okay? So this needs to satisfy the conditions for both equations, and we can say that this is the solution for this exercise, okay, graphing. Then I'm going to make a pause in here, and I'm going to ask you if you have some questions about this exercise. In the example 3, we need a problem-solving application. Bolorama charges $2.50 per game plus $2 for shoe rental. And Bowling Pins charges $2 per game plus $4 for shoe rental. For how many games will the cost to bowl be the same at both places? What is that cost? Okay, so they are two companies for bowling game. In this case, Bowl-O-Rama is the first one, and in the other one is Bowling Pins charges. The first part is to understand the problem. The answer will be the number of games played for which the total cost is the same at both bowling alleys. We list the important information. The game price for each one. The game price for Bowl-O-Rama is $2.50 and the bowling pins is $2. The shoe rental for Bowl-O-Rama is $2 and the shoe rental fee for bowling pins is $4. So I'm only going to write the equations that you have. The total cost equal the price per game times multiplied by the number of the games plus the shoe rental. You can see that the total cost is the variable y. Y is the total cost, and X is going to be the number of games. So when we make a plan, like in the example 2, we need to write the system of equations. They give you the information and we write the system of equations. System of equations, I have at least 2 equations. So we only have 1 minute, so I'm going to write the equations. For the first one, ball-orama, y is going to be equal the price per game, that is 2.5, multiplied by the number of games. The number of games is the variable x, plus the shoe rental. The cost for the shoe rental is $2. And for the other one, okay, like it's a system of equations, I'm going to write you the symbol here. And for the other one, for the second one, for bowling pins, y, the total cost, is equal the price per game, $2, multiplied by the number of games, the variable x, plus the shoe rental. So the shoe rental in this case, they are $4. We solve this and we graph. Like in the example 1, we graph, and later we obtain a possible solution that is 4,12. So I only draw the graph. Just give me 1 second. I just have something like this. Then you already have the equations, the graph of the equations. I'm not going to graph again. What happened with this? Okay. The first one is start in 4. You can see the y-intercept is giving you the point where it's going to start, and the other one is start in 2. And they are going to have a point of intersection. I only write the point of intersection and we finish, okay? And the y-intercept, 4,12. This starts in 2. You can see it start in 2. This is the y-intercept, and this start in 4, okay? So the point of intersection is this one you have in here. And what we are going to do later with this, we already graph. Imagine that you find the x and y intercept and you graph. You have the possible solution. Then you replace these values in the first equation. See if it's this statement is true. And later you prove the same values in the other equation. And if the statement is true in both equations, this is the solution of your system of equations, okay? The important part of this problem is to understand how to find the solution. And we already have the graph. So I'm going to finish in here the class, guys, because we already finished the class.